Okay, I thought of instead of telling you what my topic was, I'll do something differently. I'll give you an example which would motivate you to think why I did what I did. So, can anyone fill in this word for me? Soap, yeah, exactly. What about this one? But why did your answer change now? Yeah, your answer was predicated by what preceded the statement, right? The fill. So there was something that's happened in your mind which led you to think that the first one was soap, the second one was soup. Oops. And what about this one? If I say, for example, if Larry is tall, and if I say a skyscraper is tall, what's the definition of tall in each of these statements? Maybe tall in case of Larry, maybe in India it would be 6 feet, and a skyscraper would be maybe around 100 feet. But you see there's some vagueness in natural language. That's what I'm trying to convey here. That suppose you say you like coffee, and there's a girl in class, you say you like Shilpa. You can't say that you like coffee the same way you like Shilpa, else you'll never get Shilpa. So there's this area this is a human brain, mine is slightly smaller. There's this area in red which I highlighted, okay, that's called the Broca's area. And the Broca's area is known for, is the backbone of natural language processing. Backbone, wrong term. Okay, so what happens, and it's been found that the Broca's area is highly fuzzy in nature. And that's what I'm trying to say. This is my topic. I'm doing an extractive text summarizer based on fuzzy logic because, and if you're wondering why the other guy also did something on extractive text summarization, he copied me. So now let's correlate natural language processing and text summarization. So it turns out that when I did text summarization, I didn't use fuzzy logic at all. I just did implementation of fuzzy logic, implementation of text summarization, and it wasn't really good. And I started looking at how they evaluated text summaries, and it turns out that people evaluate text summaries based on someone else's, a human's input. Then they compare the human's input with the computer's input. And if I have to actually get a good result, then there should be some way of my algorithm mimicking a human mind. So that's what led me to fuzzy logic. And to tell you about implementation very briefly, the pre-processing step, nothing great in that. Every natural language processing algorithm has a processing step, and the output of this is a n-dimensional vector, where n is the vocabulary of the, I'm just using big words, n is the vocabulary of the document. And the feature extraction, this is what defines my text summarizer, different from, what's different from what's already available, because they say if you want to make good wine, you have to have good grapes. So grapes are here. I choose proper nouns which add specificity. So if I say something like Tommy was fat or something like that, so a sentence with a proper noun has a subject, has an important person in it. So and verbs, no one actually uses verbs, surprisingly, but it turns out that verbs connect to sentences. So a verb is like, they say it's the heart of a sentence. And TF-IDF, inverse document term frequency, inverse document frequency, it's I'm not going to go completely into that, but I use log normalization to dampen the effect. Sentence position, suppose you have a document. It turns out that the first half, the first paragraph is usually the introduction, which usually has important sentences. The last para has important sentences because of the conclusion, and everything in between is weighted appropriately. And there's numerical data and dates which have their role. And the fuzzy inference system, well, there's a fuzzifier, a knowledge base, fuzzy inference. I'll explain this in the next slide. The fuzzy inference engine interacts with the knowledge base, and the knowledge base has some rules which you define. So, for example, you usually have if and then clauses, and the fuzzy what you input to your system. Okay, let me go from here. What you input to your system is a real value. So, for example, you touch water which is 60 degrees hot. I can say hot. It's at 60 degrees. So your intuition of that is that it's not cold. You can say it's warm and it's not hot. So you can probably say that it's hot in a scale of 0 to 1, maybe 0.2. Cold 0.2, hot 0.2, and warm 0.8. So that's what your inference engine would do. It will take the crisp value, the 60 degrees input, change that into hot, cold, and warm values, and then it'll defuzzify it, as in it'll give an output, which is again a crisp value. Oops. This is a toy example which I got. So suppose if, and this is like for a music system. So if you have tempo and loudness, which predicates the quality of music, and if you have music which is at that tempo and that loudness, you find the AND of it, which is the minimum, and then you find the summation of both these graphs, and you find the centroid of it. Oops. Okay, for sentence extraction, I find the top 20 percentile of every sentence score, and then I place them in the same order, so that it doesn't change the semantics of what it's trying to convey. And results, you can see that the blue one will obviously be mine, because I didn't choose anything which was greater than mine to represent here. But the thing is that the text summarizer which I developed has production value results, so it can be used as a production standard text summarizer. But obviously they are better text summarizers, and I'm still trying to fix a few bugs in probably the feature extraction unit. But the thing is, it beats MS Word, which surprisingly has a text summarizer, and which was deprecated later. I don't know why. Maybe I saw this graph. So thank you.
Questions? Thank you.
Thank you.